Now children, a very interesting thing comes to you. You have studied Avogadro's law. Do you know how Avogadro got this law? Not it. Maybe or may not be, isn't it? Yes. I will tell you today from where he got the law. Today also I will tell you from where we came to know about the molecules. As I said you in Dalton's atomic theory, that the idea of molecule was not known to Dalton. So hence he called it as compound atoms at that particular time. The compound atom was what? Molecule. So who gave the term molecule? Alright, clear. All these things I'll tell you now. So listen carefully, it's very interesting. Alright, very interesting. Lot of things you'll come to know. Now Berzelius hypothesis. Now hypothesis and law, there's a difference. Law means which is universally accepted, and hypothesis means which is not accepted. It is being rejected in the in the initial stages. We can say that. For example, you are making project work, isn't it? So what you're doing is that you're writing a synopsis and giving it to your teacher. Now your teacher reads it and says that okay, it's fine. You continue. Then you make a project. But if your teacher says that no, it is, you write it again. So what is that? That's rejected. That's called as hypothesis. Just your thought, we can say that. You are presented. Clear? Yes. But that thought, if you carry it forward, if somebody carried forward, you carry it forward, then you may also come to a particular conclusion which can be universally accepted by everybody. Alright? Okay, fine. So let me come to Berzelius hypothesis. Now Berzelius, from where he got it? Now listen carefully children. In one of the postulates of the Dalton's atomic theory, he said that when atoms combine to form the compound atoms, they combine in a simple whole number ratio. Listen carefully. When atoms combine, they combine in a simple whole number ratio to form the compound atoms. What I said? Simple whole number ratio. Atoms combine. Fine. Gay-Lussac, what is that? Gay-Lussac says that when gases combines with one another, they do so in a simple whole number ratio by volume. Again I repeat, when Gay-Lussac, what Gay-Lussac says that? Gay-Lussac says that when gases combine with one another, it combines in a simple whole number ratio by volume. So atoms combine in a simple whole number ratio by, what you can say, number of atoms. Alright? Dalton said that. And Gay-Lussac says that when gases combine, they combine in a simple whole number ratio by volume. So Berzelius concluded that there must be some relationship between, what you can say, that gas and the atoms. There must be some relations because both are saying the same thing. Dalton is saying they are combined in simple whole number ratio. Which one? Atoms are combined simple whole number ratio to form the compound atoms. Gay-Lussac is saying that gases combine in a simple whole number ratio, alright, to form a particular product. So Berzelius found a relationship between them. He said that yes, there must be a relationship between them. Between this, what you can say, gases and the atoms. And hence what he said, please note it, this particular thing, this hypothesis. He says that equal volumes of all gases under similar conditions of temperature and pressure contains same number of atoms. He combines both Dalton's atomic theory and Gay-Lussac's law of gaseous volumes, and he said that equal volumes of all gases under similar conditions of temperature and pressure contains same number of atoms. Alright, I think you have written it, this particular thing. But I said same number of atoms because this word is very important. Same number of atoms when equal volumes of all gases under similar conditions of temperature and pressure combines. Okay. Now we have to also verify this particular one, the statement which you have given. We need to verify also. Simply we cannot give a statement and we can say it is accepted. We need to verify. For that reason, what Berzelius did, see, the one which I am going to do, it is the work of Berzelius. Alright, Berzelius is given this particular thing. I am not doing. Alright, clear? So understand it. So here, that is hydrogen when combines with chlorine, what it gives? It gives hydrogen chloride. So what you find is that here it is one volume of hydrogen. Here it is one volume, and here you will see that it is two volumes. How it is two volume? If I write it in symbol, what you will get it? H2 gas plus Cl2 gas gives how much? 2HCl gas. We can say that. Clear? So H2 gas plus Cl2 gas gives 2HCl gas. So fine. Now here it is, according to Berzelius, n atoms, he says that, audit, that is same number of atoms he said. So n atoms, one volume means how many atoms? N atoms, audit. And here also one volume means how many atoms? N atoms. And here it is 2n, 2 volumes means 2n, 2n compounded atoms, because I said you molecule was not being known to us at that particular time. We will know about the molecules now. So that means one volume contains n number of atoms, here also contains n number of atoms, and here two volumes of HCl contains 2n number of compounded atoms. Got it? Now what Berzelius did, he divided throughout it by 2n. Got it? That means he divided throughout by 2n. When you divide it throughout by 2n, so what will you get? Half atom. Here you will get half atom, and here you will get one compound atom. What I said? Divide by 2n throughout. You divide by 2n. So n by 2n means, and then cancel half, and in this way it is one compound atom. Now come to it. So here, what I said you, Berzelius, how he made this hypothesis? By combining Gay-Lussac's and Dalton's atomic theory. One of the postulates, we can say that. So Dalton atomic theory says that, clearly says that, atom is indivisible. You cannot divide an atom further. But he has divided it, half atom. He has divided it, you can see, ultimately what he got. This is a work of Berzelius only, not mine. So in this way he got half atom. Clear? So hence his hypothesis was discarded, because it contradicts Dalton's atomic theory. With what he took and made this hypothesis, lastly contradicted that only. Dalton's atomic theory says that clearly atom is indivisible. You cannot divide an atom. Got it? But here it is divisible. Atom is divisible. You can see half atom. That means it contradicts directly Dalton's atomic theory. For that reason, it was being discarded. Berzelius' hypothesis was being discarded. Got it? I think it's clear, Berzelius' hypothesis? Fine. Now, after this, Avogadro. Avogadro. Got it? That is Avogadro law. Rather, I will come to it. Now, Avogadro, at that particular time, Avogadro, who was watching the Berzelius hypothesis, got it? He said that, first of all, he gave the definition, the correct definition of an atom and molecule which are having it today. First of all, Avogadro did this correct thing. He gave the definition of an atom and molecule. So what is an atom today? We know it. Atom is the smallest particle of an element. Listen carefully, write it down. An atom is the smallest particle of an element which may or may not have an independent existence. Smallest particle of an element. Element means oxygen, nitrogen, iron, calcium. So smallest particle of iron is iron atom. Smallest particle of oxygen is oxygen atom. So smallest particle of an element which may or may not exist independently, that is an atom. That is the definition of an atom. Now I will tell you where it is may and where it is may not. In case of inert gases, it exists independently. That is may. But in case of other gases like hydrogen, chlorine, oxygen, nitrogen, does it exist? No. It exists in which state? Molecular state. So it is may not. In that case we can say that. Okay. Now next is he gave also the definition of molecule. Yes, Avogadro was a person who told us about the molecules. He told us about atoms and molecules. Avogadro was a person who told us. So what Avogadro said? Avogadro says that the smallest particle of a substance which have an independent existence is a molecule. Molecule is the smallest particle of substance. Remember that. Atom is the smallest particle of an element. But molecule is the smallest particle of a substance. Substance means what? See, this is a pen. It's a substance. So what will I say? Will I say one atom of pen? No, one molecule of pen. Water is a substance. What will I say? The smallest particle is one molecule of water, one molecule of sugar, one molecule of wood. He will never say one atom of sugar. Absolutely wrong. Because sugar is not an element. Sugar is a compound. It's a substance. So it's the smallest particle of a substance which have an independent existence. Does it not exist independently? Yes. Water exists independently. Sugar exists independently. So which have an independent existence is nothing but a molecule. So for the first time we got the definition of an atom and a molecule. We came to know about the atom, but we did not have an actual definition. Today we came to know about the actual definition of an atom and a molecule. Fine. So hence Avogadro says that gases does not exist in the atomic state, it exists in the molecular state. He also proved it. Later on we'll prove it also. The atomicity of the gas, I'll prove it and I'll say you. Alright. First, Avogadro says that the gases does not exist in the atomic state, it exists in the, what you can say, in the molecular state, because these gases. Now you may say that, sir, inert gas exists in the atomic state, right? But inert gases, does it combine with any other, what you can say, other gases? Or does it combine with each other? No, that's it. So hence, the gases which here Berzelius is talking about, they do not exist in the atomic state, they exist in the molecular state. First, Avogadro said this particular statement. He corrected it. Then, what he said? He said that, see how clever he was, Avogadro. For that reason, he was given the credit, and today we come to know as Avogadro's law. Just what he did, he changed one word. Now, what is Avogadro's law? You might be knowing it. Again, I repeat. Equal volumes of all gases under similar conditions of temperature and pressure contains same number of, what I said, molecules. Everything remains the same, what Berzelius says. Just he changed the atoms into molecules. Again, I repeat what Avogadro says. Equal volumes of all gases under similar conditions of temperature and pressure contain same number of molecules. Instead of atoms, he used as molecules, and hence it was accepted universally and it became a law. So how we will prove it? Same thing, like Berzelius, we are also going to prove it. So Avogadro took the same thing what Berzelius did, but he did some corrections. So what he did, let us check it here. So, are you following, children, what I am saying? It's very interesting. So listen carefully. So here, instead of n atoms, as I said, it does not exist in the atomic state. Already it was said by Avogadro. It exists in molecular state. So I'll write it as n molecules. Here also I'll write it as n molecules, and here I'll write it as 2n molecules. Because compound atoms was now not considered, it was considered as molecules. Same thing what Berzelius did, he divided by 2n. He divided throughout by 2n. So I'll also divide it. So what will I get? Half molecule. Here what will I get? Half molecule. And here will I get 1 molecule. Alright. So what do you find here? We got half molecule. Molecule, yes, molecule can be divided. Molecule can be divided, atom cannot be divided. Alright, the atom said that atom is indivisible. He did not say that molecule is indivisible. We can divide a molecule, yes, why not? Like this hydrogen, it's a molecule. It is made up of how many atoms? 2 atoms. Alright, so it is divisible. Chlorine, it is divisible. It is made up of how many atoms? 2 atoms. We'll prove it now. Atomicity of the gas, we'll find it out and we'll prove it. That it's made up of 2 atoms. This is made up of 2 atoms. We'll prove it. Alright, in this way, what we find is that he did it as a molecule, and hence it was accepted, because molecule can be further divided into atoms, but atoms cannot be further divided. We can say that. Clear? Can you divide an atoms and get, what is that you will get it? You tell me. Suppose if you divide an atom also, what you will get it? You will say I will get electrons, protons, neutrons. No, it is not divisible. Use the correct statement. Many of the children says it wrong. Use the correct statement. What I said to you, atom is not divisible into subatomic particles. Atom consists of subatomic particles. Use the correct word, then only you will understand it correctly. Alright? I think it's clear to you this particular one, from where Avogadro got the law, the Avogadro's law. Thank you very much.